In this video we are going to discuss about carry look-ahead adder. So while designing a fast adder, it is essential to get around the rippling effect of the carry that is present in one form of or another in both the carry bypass and carry select adder. The carry look-ahead adder, it offers eliminating this rippling effect by, we know that the relation of the carry, right? The carry is equal to AI Ci is equal to Ai Bi plus Ci minus 1 Ai XR Bi. This Ai Bi I can write it as generate G, and Pi, this is nothing but propagate is equal to Ai XR Bi. So if I substitute, if I want the C1, I have to substitute I is equal to 1. If I substitute I is equal to 1, I will get C1 G1, Cn is equal to G1 plus C0 P1. This is your first equation. Next, if I substitute I is equal to 2, I will get C2 is equal to G2 plus C1 P2. So substitute this first equation in the second equation. I will get C2 is equal to G2 plus G1 P2 plus C0 P1 P2. So you can see I have eliminated the C1, right? I have eliminated the C1 here. So likewise, if I substitute C3, I will get C3 is equal to G3 plus C2 P2. If I substitute I is equal to 3, and this is your third equation. And if I substitute this fourth equation in the if I substitute fourth equation in the third equation, I will get this fifth equation, right? So this C3 is independent of the previous value, like C2 and C1. So thus the ripple effect is getting eliminated. So if I want to generate the sum, we know that the sum is equal to A XR B XR C, right? So if I want to generate S1, I can write P1 XR C1, right? So likewise, if I want to implement Sn, Pn XR Cn. Okay. So this is your final equation. C3 is equal to G3 plus G2 P3 plus G1 P2 plus P3 plus C0 P1 P2 P3. Okay. So how to implement this one? So if I want to implement this, now I am going to implement this G3 plus G2 P3. So this is nothing but G2 is in series with P3. So this is G2 P3. So I have to multiply this one, since G2 is in series with P3, and this whole term is in parallel with G3. So I am writing G3 plus G2 P3. So this G1 P2 P3, this G1 P2 P3 is in parallel with this whole term, right? So I am writing G1 P2 P3 is in parallel with this whole term. Likewise, I can write C0 P1 P2 P3. C0 P1 P2 P3. C0 P1 P2 P3 is in parallel with this whole term. Okay. So this is how I have got the value of C3 bar. Okay. So similarly, if I want to implement then the P mass means you can see C0 P1 is in series. So I have drawn C0 P1 is in parallel, and I can see P1 and G1 is in parallel. So I have So I have drawn it in this whole term is in parallel with this whole term, right? C0 and G1. C0 and G1 is in parallel, so I have drawn it in series. Okay, C0 and P1 is in series, so I have drawn it in parallel, and C0 and G1 is in parallel, so I have drawn it in series. Okay, so similarly you have to draw it for the rest of the circuit. Okay, so by doing it, so you can see the fan out get increased. The fan out get increased excessively if I increase the number of n, right? So which will slow down the adder more. So therefore you should slow down the adder by increasing the area, right? So therefore the look-ahead adder structure is useful only for the small values of n which is less than 4. So this is your drawback. So thank you for listening to this video.